Okay, so you're going to write out your formulas. Number 1 is going to be AB is equal to this whole thing. Number 2 is the big M for McDonald's, which is your midpoint. It's the x1 plus x2 divided by 2. It's the average between the two. Divided by 2, that's your midpoint. Number 3, you're going to write out your gradient. My favorite formula is the change in y over the change in x. Change in y over change in x, which is basically y1 minus y2 over x1 minus x2. Then your last one, very important, if you don't write them all out, don't just write like this. It's just that this pen is a bit more tough than you know to work with. And then number 4, very importantly, m1 times m2 gives you, you've got it, minus 1. That's for a perpendicular line. That means 90 degrees. It's not for parallel lines. Parallel lines, the m is equal to the m. So if I've got y is equal to 2x plus c, both lines gradients are 2. Okay, to see it now. That's nice. Okay, cool. Let's dive in and have a look at this. This is November 2017, so you're going to get something like this. The diagram below, I've got P, Q, R, S. I've got some variables in S, T, and K. Are the vertices of quadrilateral, P, Q, R, S. Quad meaning 4. Cool. Calculate the length of P, Q. Length and distance, length and distance, length and distance. I wonder which formula we should use. So you're just going to go la, 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 la. And that's for 2 marks, and you just got your 2 marks. Cool. 3.2. If T, okay, T is whatever, is the midpoint of Q, S, so it's kind of the midpoint of the diagonal. Determine the coordinates of S. Okay, so you go, what the heck is going on here? Oh my gosh. What have I got to do? I've got to go QS. Okay, QS has a distance. What is the distance? Well, I can write it out and I can say distance formula, and then you're going to get some variables in here. You're going to get a variable as a t and a variable as a k, and then you're going to go, okay, what the honky donk do I do with that? So instead of doing all of that, you can just do the midpoints, because I think we're going to use that later anyway. Find the length of this thing. What you can do is you can use the midpoint. And you go, okay, the distance formula doesn't quite work. Let's see if we can use the next formula for our McDonald's. And I've got x1. Here's my x1, which is 6. x1 plus x2, which is t, plus t. Let's work only with the x's for now, because that's how much space I have for now. 6 plus t divided by 2 is going to give me 7 over 2. Okay, because this is the end point. This is the midpoint. This 7 over 2 is going to be my midpoint. Now I've got a variable, which means I've got to figure out what the variable is, because I wasn't given the variable, I was given the end point. Okay, here. So, what is t? 6 plus something over 2. What can I do to this equation? Well, I can times both sides by 2 over 1. I want to get this a little bit less messy. So, let's unmess this a little bit. So I can say midpoint, exactly what you're thinking. Exactly what you're thinking. Very good. 6 plus t over 2 is equal to 7 over 2. I can times this by 2 over 1. What I do to the one side, I do to the other, because this is just an equation now. So this cancels out. This cancels out as well. Well, that's quite nifty. So 6 plus t equals 7. Try to write this out so that you don't think, well, t is equal to 7 plus 6. Oh, no. Then we've done Zoomer numbers there. So what do I do to get this t by itself? Well, I actually minus 6 this side and I minus 6 this side. So 7 minus 6 is 1. So t is actually going to be 1. So t is going to be 1. And it looks about 1. Because if this is 6, kind of. Not drawn to scale, but it looks like 1. So t is 1. Very easy. Only because you've drawn out your formulas. The first formula, as soon as I said length, it didn't work out. Put the next formula in, and it'll work out. Cool. So let's work out the y value. So k. So the y value of this big M for McDonald's is y value is 6. And the y value is k, so 6 plus k, and it's probably going to work out exactly the same as the other one, where I know you know the answer already, because you're going to times that by 2, times that by 2, this is going to go away, this is going to go away. I'm going to have 6 plus k is equal to 7. I'm going to take that over, or rather minus 6 from both sides is a better way of saying that, and k is going to give me 1. It was because these two are exactly the same, the next variables, and these two are the same. The next variables are going to be exactly the same. So, cool. So, I'm looking at 1, 1. That wasn't too difficult. It was just finding the formula. If the first formula doesn't work, try the next formula. So, this is going to be 1, 1. Cool. Determine the coordinates of S. S is 1, 1. Now, why have they asked you to determine the coordinates of S? The coordinates of S, hello. That's nice. I told it. Show that PR is equal to QS. So PR, oh, we got some diagonals going on here, is equal to QS. Diagonals, well, we got a point here, and we got a point here, so we can find that distance with this formula. La 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 la. In other words, you're going to use this point to find out this distance. Distance formula. La, 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 la. Cool. So the distance, use the distance formula and find that out. Cool. That is already 2 marks, 3 marks, 2 marks. You've basically got 7 out of 16, which is almost 50%. It's about 45, somewhere around there. Is that coordinates? Okay, show that QR. Aha, look at our next formula. What was the next formula? The formula number 4 was M1 times M2 equals minus 1. Show that QR is perpendicular to RS. Show that those 2 lines are perpendicular. Now, this is for 4 marks. So, we don't know the gradient yet, because it's when the gradient, 2 gradients multiplied give a product of minus 1. So, we're going to find out the gradient. How do we find out the gradient? This is the 4th formula. The 3rd formula, very, very importantly, the 3rd formula is gradient is change in y over change in x. Yay! y1 minus y2. So, let's see. For 3.4, we just go through our list of formulas. Once you've written those formulas, man, you have knocked the ball out of the cricket field already. Cool. So, show that these 2... So I need the gradient here. So let's do a quick gradient. 6 minus 3 is 3. And 6 minus 0 is 0. Change in y. This is change in y over change in x. So 6 minus 3. Oh, 6 minus 3 is 3, and 6 minus 0 is 6. That looks like a half. Okay, the gradient is a half. Now, for this one, let's find the gradient. Once you've got the formula, man, the rest is so easy. 1, 1. So let's say change in 1 minus 3. 1 minus 3 is minus 2. 1 minus 0 is... Oh, it went somewhere else. 1 minus 0 is still 1. So I've got negative 2. And I just found out that my other gradient was a half. Does it work? A half times 2. And you can even write whatever you want if it makes sense. Does a half times minus 2 over 1 equal minus 1? Oh, yes, it does. Yeah. Fantastic. And that is 4 marks. 4 very easy marks if you've written your formulas down at the beginning. So that you've gone through the formulas and gone, okay, how do I get the gradient? So you're not working with all these m's. Where are all these m's? Because 3 of those formulas have m's. So the big M, the gradient M, the big M for the midpoint, the gradient M, and then the gradients to get to perpendicular. Once you've got those, you pick them out and done. That is 2 and 2 is 4, 4 and 4 is 8. That's 11 marks out of 16. That's fantastic. Okay, what type of special quadrilateral is? Now, they're not just going to hit you with some weird question in the middle of everything. What did they just ask you here? And this always happens in every analytical geometry. They're leading you into the next answer. Even here, they say determine S. Well, if you didn't get S, let's give you S. Everything is leading on. So, yes, got an amen from the bird. Hence, what type of special quadrilateral? Blah blah blah. I've got a 90 degrees here. I've got a 90 degrees here. I wish I could draw this 90 degrees. It would be awesome. Pretend that this is really amazing drawing with my pen that I need to learn to use. That's 90 degrees. Okay, so I've got 90 degrees. A quad that's 90 degrees. It could be a square or a rectangle. That does not look like a square at all, because these look much shorter than these. But that's not a reason that you would put. You would say 90 degrees. And did we work out any diagonals? No. You can work out lengths. Diagonals equal. You can work out these two diagonals if you want to. It'll take a bit of time for 2 marks. You can do the distance formula. But you did the length of PQ, and you can figure out if these two lengths are the same. You can figure out if the diagonals are the same, because diagonals are equal. Diagonals also bisect each other. There's a few different things you can do, but I would just say I would try and find the diagonals length. I would do that formula, and then I would do that formula and prove that they're the same length. That's what I would do. Cool. So I would say it's a rectangle because of the corner and the diagonals being the same length. Calculate the size of RSQ. So RSQ. I'm wondering if this is... okay. This has been moved to Tuesday. That's awesome. Cool. I'm glad. Cool. Okay. So diagonals would be, I would say they're the same. Calculate the size of RSQ. Now, if I'm given a triangle, they want an angle. Now, I've already got an angle here, and they want another angle. And they've given me some lengths. And what we know from normal geometry is, okay, let's try and find this. Where's that right angle? Okay, the right angle's at R. What other... Hello, birds. What other stuff have we got? We've got an S, draw the S here, R, S, and a Q here. Okay. Make sure your your 90-degree angles in the right place, because if in the wrong place, sure, you're going to get strange angles, causes instead of sines. I'm going to right angle triangle. This means that this is the hypotenuse. Hello, birds. This means that this is the hypotenuse. This means, what do I need? I need the S. So I need this angle here. And if I've got that angle that I need, what can I use? I can use opposite over hypotenuse. So I can use sine. I can also use cos. RS. Have I got the length of this? I can work out, this is for 3 marks. So you're probably going to do 3 different things. You've drawn your triangle. This is adjacent over hypotenuse. Adjacent would be RS. Find out RS, the length of RS, through, oh, it's getting loud in here, through your distance formula. Then say RS over that hypotenuse. The hypotenuse is the RSQ. The hypotenuse is this diagonal. So you're going to find out that diagonal with the distance formula. Then you're going to say opposite over hypotenuse is going to be, or adjacent over hypotenuse, sorry. So the one we've chosen. I like red, but I'm feeling for that one. So I'm going to say cos, because it is adjacent to this angle over the hypotenuse. And I'm going to say cos theta is equal to, work out the distances of those. I actually just worked it out now. And RS was square root of 5. And I think RQ was 5. QS was 5 square root 2. Oh, 5 square root 2. So you're going to have adjacent over hypotenuse, which is going to be square root 5 over 5 square root 2. And you're going to work this out. And theta, this angle is going to be equal to 71.57. As soon as it becomes some 71.57, I really need to use this pen. I need a manual or a tutorial on YouTube of how to use this pen. As soon as it becomes some weird number like 682, you know you're going wrong, because there's only 180 degrees in a triangle. Write your formulas out and you're done. All the marks in the bag. You should get at least 80% for all of this.